Okay, so our second part of concept 36 deals with one type of special right triangles. They are 45, 45, 90 triangles. So we'll break down their specific properties and how we calculate their sides. Um, Now, previously we calculated the sides of a triangle based on the Pythagorean theorem, and a squared plus b squared is equals c squared. But that works for all right triangles. Now, um, with 45, 45, 90 triangles, the Pythagorean theorem works as well, but thankfully we know some properties about triangles that make calculating the sides a lot easier. Um, so in these triangles, you'll notice that you have two sides that are the same. This side and this side are the same, and in fact, this angle and this angle are the same. What this does, it makes it a isosceles triangle. It's an isosceles triangle. So we know that isosceles triangle has two equal sides, two equal legs, and a hypotenuse. So if we said that each leg is the same, x and x, we find that to find the hypotenuse, we multiply the leg by the square root of 2. So the leg is x, and the hypotenuse would be that leg multiplied by the square root of 2. Now there's some really cool ways for us to calculate how to find those pieces. If we know one, we can find the others. So to find hypotenuse, like I said, you would just take the leg of the triangle, either leg, because they're the same, it doesn't matter, and multiply that by the square root of 2. And if I know my hypotenuse and I want to get to my leg, I would take my hypotenuse and divide it by the square root of 2. So I just kind of do the inverse operations there to get from one to the other and in reverse. So this is also called an isosceles right triangle, like I mentioned. Isosceles right triangle. And we'll come back to that blank space there. So let's use this information to find the missing variables that we're looking for. So right off the bat, I know that I can find y, because y is the same as, so this side is the same as this side. So since this one leg is 25, then the other leg has to be 25. And I know that to find my hypotenuse, I take my leg, which is 25, and I multiply it by the square root of 2. And I leave it just like that. Like, I don't need to simplify it any further because you're going to get some gross decimal. We don't want to do all that. Let's do it again. For example 2, since one leg is 8, x is the other leg, and it has to be 8. And again, y is my hypotenuse. It's my leg. It's my leg times the square root of 2. Easy peasy. Let's look at some other examples where they get a little trickier. Now I know my hypotenuse, and I want to get back to my leg. So now I know that I need to divide by the square root of 2. Well, when I do that, 10 square root of 2 divided by the square root of 2, well, I know that these square roots cancel each other out, and they go away. So x, my leg, must be 10. And in turn, y must be 10 as well, because it's my other leg. For example 4, it shows that we know a leg, and we need to find the hypotenuse. So there's actually supposed to be a y up here, but again, y is just another leg, so I know that's the square root of 6. To find x, I would take the square root of 6 and multiply it by the square root of 2. Well, as we practiced in the previous lesson, I know that the square root of 6 times 2 is just the square root of 12. And for that matter, I know that I can break this apart into the square root of 4 times 3. And therefore I can simplify. This part becomes 2, and the square root of 3 remains on the other side. So 2 square root 3 is my hypotenuse. It is important that we simplify as much as we can when we solve these answers. So square root of 12 would be correct, but it's not in its simplest form. Let's try some more examples. I know right off the bat that y is equal to 2 square root 3, and I need to take that and multiply it by the square root of 2. So I get 2 square root of 6. Remember, I can only multiply numbers, two numbers, if they're both in the square root. If they're both in radicals, then I can just multiply them. But I leave the 2 on the outside, I leave that the same. That has not changed. So 2 square root 6 is my result. Here's where we get a little tricky, and the technique we learned in the first part with rationalizing the denominator is going to come into play here. So I need to divide my hypotenuse. I need to divide my hypotenuse by the square root of 2. Well, we know that this is irrational, right? It looks crazy, and we need to rationalize it. So I need to do that by multiplying by the square root of 2. And I get 19 square root 2 over just 2. Well, I can't divide 19 by 2, so I would literally leave it just like that. So that is my leg, so that's x, and that's y. 19 square root 2 over 2. That's that. Nothing else to do. A couple more problems. If I have 4 as my hypotenuse and I want to find my legs, I'm going to take 4 and divide it by the square root of 2. And I know that I need to multiply this by square root of 2 over square root of 2. And I get something like that. And I know that I can cross cancel the 4 and the 2 to get 2 square root 2. 2 square root 2. And that's both legs. Both legs are 2 square root 2. One more problem. Same deal. There's supposed to be a y here. So again, we're going to take 4 square root 6, which is our hypotenuse, and divide it by the square root of 2. And then we multiply it again by the square root of 2, like that. And we get 4 square root 12 divided by 2. Now I can simplify this. The 4 and the 2 again become 2 square root 12. Now we learned earlier that the square root of 12 can be simplified. Let's go back and look. Up here, we simplified the square root of 12 into 2 square root 3. So in other words, 2 times the square root of 12 becomes 2 times 2 square root 3. Well, again, I can simplify it by multiplying the numbers that are outside the square root. So this becomes 4 square root 3. 4 square root 3 for my legs. And that's that. So 45, 45, 90 triangles are really, they're really easy to solve once you know that little trick that the legs are the same and the hypotenuse is just the leg times the square root of 2. Stay tuned for 30, 60, 90 triangles.